Good evening, everyone. Welcome to the Global Math Department. My name is Lee Natero, and I will be your host for the meeting tonight. Tonight, we're going to be hearing from Jennifer Fairbanks about creating a thinking classroom from the VNPS and VRG to the lessons to the aha moments. I would like everybody to introduce themselves in the chat window, telling us what you teach, where you teach, and what your Twitter handle is if you have one. I see a lot of familiar faces here this evening. Welcome. I hope that for some of you, your classes are still in session, and for others that you've been able to make any necessary adjustments to teaching and to your life. So before I introduce our speaker, I'd like to explain a little bit about how these meetings work. These meetings are recorded and are available about 24 hours after the meeting ends. To view the recording, you would use the same link you used to get here tonight. The global math community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. I'll be sure to catch your questions for the presenter to be added at the end of the to be addressed at the end of the presentation. Our speaker tonight is Jennifer Fairbanks. Jennifer has been a high school math teacher for 15 years at Hopkintown High School, where she lives with her husband and 4 sons. She also coaches the boys cross-country team and the math team. Jennifer is a 2017 Presidential Award finalist and a 2017 Desmos Fellow. She's very active on Twitter and blogs at 8ismyluckynumber.blogspot.com, where she enjoys sharing classroom ideas. Jennifer is interested in providing opportunities for all students to be invited into math problems by having them work in groups at vertical whiteboards. At this time, I'd like to turn the presentation over to Jennifer.
Let's see. Good evening. Can you hear me? Okay, great. Welcome. It's so fun to watch the new names pop up in the side window. Some I recognize and some are brand new. And it's also very exciting to see from all over the country and Canada. So thank you for joining me tonight. I was asked to make this presentation for the Global Math Department back in December, and it seems like a lifetime ago now. I knew that I wanted to present on vertical whiteboards, and I put this presentation together over February break. So it was before Corona and all of that stuff. So I'm just going to move forward as if none of that is going on. And then at the end, maybe we can share some of our stories on how our schools are dealing with this. Can anybody hear me? I see a few of you have lost sound. Okay, let's see. Oh, okay. People can hear me though? Okay, all right. So thank you, Lee, for introducing. Yes, I have been teaching public school for 15 years. I actually teach at the high school that I graduated at and my husband graduated at, so we've been here for a while. I'm active on Twitter and I do blog. 8 is my lucky number. .blogspot.com, and that's where I like to go to Twitter and other blogs, get classroom ideas, and then share them there. Also, I've included a bit.ly link to this presentation, so you can find that after, and this presentation has its own links inside. So what I thought that we would do tonight is start with a poll, see where we're at as far as using the whiteboards in the classroom. I'm going to share the hashtags and what they mean. I'm going to talk about my journey and how I came into working with the vertical whiteboards, talk about what they are and VRG, which is visibly random grouping, talk about how I changed my classroom and got more whiteboards from my classroom, get into some of the lessons, and I will be sharing student work with it as I go through, talk about how I create them, and then at the end, I will share some links to the board problems that we use in class. So just a quick poll, if you can tell us where you're at with your use of vertical non-permanent surfaces. So in the message, you could type just a 1 that you're starting to learn about it, a 2 that you've tried it a little bit, and a 3 that you use it a good amount. Awesome. It looks like an interesting mix. We have a good amount of 1 and 2, so thank you for coming and trying to learn more. And to my people who have responded with a 3, I invite you to share and chime in the side window, comment, and then maybe at the end share if you have some more ideas with this. Thank you. So the hashtags, because I'm on Twitter and talk about the hashtags, and if you are on Twitter, you can follow these different threads if you want to continue to learn more. So VNPS stands for the vertical non-permanent surfaces. Visible random grouping, I will be talking about how I do that and why it works. The MTBOS is MTBOS, that stands for the Math Twitter Blogosphere. I got started with that a long time ago. It's just a combination of people who use Twitter and blogs, and it has really changed the way that I teach. Twitter Math Camp is hashtag TMC, that is now defunct, but I have attended 3 of them and they had a great impact on me making my decision to bring the vertical whiteboards to the classroom. And of course, there's NCTM, the National Council of Teachers of Mathematics, and I have been to a couple of conferences and heard about the vertical whiteboards at them as well. So just a reminder that this is just my journey. It's a process. It's still evolving. Like other ideas, I take what I read on Twitter and then I try to make them my own. And I encourage you to do the same. So my timeline, I started teaching back in 2005. 2012 was when I started on Twitter. And through Twitter, I would read a lot of blogs. I was reading Dan Meyer, all of that. And then I decided to start my own blog, mostly so I could have a blog role so that I could get to other people's blogs to read them. Very active in the blogging, sharing lots of ideas. I love to have it to look back on and reflect. I use it in my teacher portfolios still. I love to look at past things that I have since given up on. And just recently I wrote my 300th blog post. So I will keep that going as a way of reflecting on my teaching. In 2015, I attended NCTM Boston, and it was the first time that I really heard about vertical whiteboarding. 2016, my colleague Kathy and I, we finally got to attend our first Twitter Math Camp. We had been trying to go for a couple of years, but we were able to attend it in Minneapolis, and it was fabulous. It was everything that we wanted it to be and more. And at Twitter Math Camp, we heard more about the vertical whiteboards. So that was in July. When we came back in August, we made the commitment that we were going to decide to change our classroom into it. We were going to change the way that we taught the problems, the way that we had the kids at the boards, which meant that we had to get new whiteboards, more whiteboards. And to the present day, I am still creating new problems as I work on this. So in 2016, when we were getting ready to take it on our own, we went to Home Depot. We bought the bath board that measures 4 feet by 8 feet. We had them cut it into 4 feet by 4 feet squares. You can see the 2 in the middle. There's a heater at the bottom. They are pretty heavy, so they would sit on that. I had the strongest duct tape, the strongest Velcro that you could find, and then I put duct tape around the edges just to make them not so rough. And then the one that's off to the right, that doesn't have a heater underneath, so I used 2 command hooks to carry the weight of those. And those boards lasted me for 2016-2017 school year, so I was really happy with that. And I can suggest that as a way to get started. In the spring of 2017, my colleague Kathy and I decided to apply for a grant through our school, the Hopkinton Education Foundation. Thank you very much. They gave us a grant and it allowed us, you can see I already had the whiteboards at the back and the front of the room, and then they gave us real whiteboards in both her classroom, my classroom. They gave us, they allowed us to take a class through going with Twitter Math Camp because we were presenting at Twitter Math Camp, and they also allowed us to get magnetic whiteboard graphs to go on the boards, which we really love to use. In 2017, that was the second time that Kathy and I went to Twitter Math Camp. This time it was in Atlanta, and I presented a 1-hour session on vertical whiteboards. I was loving vertical whiteboards. I kept blogging about it, so I wanted to share it, and I really loved the format and felt comfortable at Twitter Math Camp. So it was a great experience on applying. So in 2018, we decided to jump in and present a big session, the morning sessions. So one thing I loved about Twitter Math Camp was its schedule. It was basically 3 days long, and in the morning there were 3 morning sessions, and you committed to 1 morning session. So the morning sessions were from 9 to 12, and you would go to that session all 3 mornings. So you could really delve deep into the content that you were discussing. Also, as a presenter or a participant, you got to know your group. So I really liked that. And we focused on geometry, discovering geometry through drawing and discussion from verbal cues at the whiteboards. So this is what our plan looked like when we went to Twitter Math Camp on Thursday morning. We had our participants up at the board. They were being the students. We were reading through the problems exactly how we would read the script, with the students pointing out from the teacher point of view what we would be doing. And then on Friday, we shared how we write up our scripts, how we might take a worksheet and convert it, take an activity and convert it, thinking about every detail that you have to put in when you are describing something orally, if you're making it an oral problem at the board. And then as a group, we were still concentrating on geometry. So we were brainstorming possible geometry topics that would lend itself well to whiteboarding. And then Saturday came, and it was time for my participants to actually get to create their own problems. So they had broken up into groups on Friday, so they knew who they were going to work with and what their content was. And then they took those problems, they took the time, they were able to sit down and create the script, thinking about the order, the scaffolding. And then we got to try it out with our participants. So then they became the leaders of the session. They ran through their problem, and then they could learn how they had to tweak it. It was also fun because they were really standing for most of the morning, and I had brought in some cookies for snack. And so when we took a break, they were very excited to sit down, to finally get to sit down and eat their cookies. And I said, it really struck me because I was like, most teacher PD, you're sitting down and you can't wait to take a break so you could stand up. So I thought that was a funny thing. A little bit about who is involved in vertical non-permanent surfaces. And Peter Liljendahl, forgive me if I'm saying it wrong. He's really the one that has done a ton of research on it. He has written papers. You can find more if you just Google. You can follow him on Twitter. But he is kind of the person that I see spearheading this whole thing. Alex Overwick from Canada, I call him the messenger because he was the first person that I heard speak about it at NCTM Boston. We met up again with him at Twitter Math Camp and continue to hear about his great work. And then Laura Wheeler, she also does a great job with the sketch notes that I'm going to show you in a minute. She really uses her visual drawings to get the point across. And this is a sketch note done up by Laura Wheeler from the research of Peter. And you can see, if you're questioning why would I use vertical non-permanent surfaces, the vertical is important. Peter has done research on horizontal versus permanent versus vertical. And the vertical is important because the group can see it, the group of the 3 students. Everybody else can see it, and the teacher can see it. And I love just standing in the middle of the classroom, and it feels like a fishbowl. I can see all of their work. I can hear all of their conversations. So the vertical part is really important. Here's also a reminder, you can use chalkboards, you can use windows. In the bottom left, the notation, they are so quick to the notation. They are eager to get up. My kids will come into class and they'll look at the agenda and they hope to see that board problems are on the agenda because they want to see who's going to be in their group and what kind of work they're doing. The nonlinearity is so interesting to watch. If it's a bigger multi-step problem and they've got graphs and equations, at the beginning of the year, they're kind of all over the place, maybe not the neatest handwriting, that kind of thing. But as they realize that other people are looking at their work, they start to get neater, more organized. Still doesn't have to be in a straight line. They can put a graph, they can, make the connection to the equation. They also know that I might come around and snap a picture of it, and then I call it the paparazzi. And so they want to have their work be the one that gets the picture taken. And in the bottom right, the mobility of knowledge, I'm going to share a little bit of how I do that with my groups and how we might rotate and do a gallery walk and actually get the chance to look at other students' work. The VRG stands for Visibly Random Groups, and through Peter's research, groups of 3 are the best. So yes, you have to go to groups of 2. Yes, you have to go to groups of 4. That's okay. Yes, you might have students that don't want to work with each other. Those are bumps in the roads that you can come across. I will talk a little bit about trying to start this at the beginning of the year, working with special types of problems to get the kids knowing that they can work as a team with somebody else. I do different groups every day. And so then my students, they really don't complain anymore. They just know that's how it's going to be. So this is important. And what I use, different teachers on Twitter use different things, but I use a really great website called flippity.net. It's pretty easy to use. You can see, this is just a screenshot, but you can see all the tabs across the top there. You would go and you enter your students' names in an Excel spreadsheet, and then you don't forget to hit publish. That was one of the things that wasn't working for me right away. And then you can just hit 3 teams. You can see I don't have a number that's divisible by 3, so I went to 7 teams, and the kids working in 2. I do prefer teams of 2 over 4, just because 4, it's too much standing around and poking each other, but 2, they are a little more accountable for their work. So check out flippity.net. Even if you're not going to use vertical whiteboards, it's also a great thing just for making groups. You can make seating charts, that sort of thing. So some of the lessons that I'm going to share with you today, and these are some of the ideas that we're going to talk about. If you think the beginning of the school year, types of problems that might be starters for just learning how to work in groups. Also at the beginning of the year, learning the importance of special math notations. And then things that we do all year long: investigate patterns, discover, activating prior knowledge. Of course, what do you notice? What do you wonder? Making connections. I don't do this every day. There are plenty of days that I direct teach. But you can direct teach, and then you can have them get up to the board and apply it or practice it. You can spiral. You can teach one day and then spiral content in Algebra 2 that they've had from Algebra 1. The biggest thing that I love about it is identifying the mistakes. I can see their work as they're working. It's not down on a piece of paper, covered up by them. And I can make notations to the entire class, not just that student, because if that student makes it, somebody else may make it. Remember your units. Do you need a capital letter in geometry to describe the angle, or do you need a lowercase angle? Is there some calculator mistake that they're all making? So trying to cut those mistakes before they become permanent is one of the biggest bonuses that I love with the whiteboarding. Challenge problems, maybe something that you couldn't give them individually, but now that they're working in a group situation, they know that they have 2 other friends they can rely on. They're more likely to persevere and work through a challenge type of problem. Asking them to create their own problems. They have this whiteboard in front of them. They love to draw on the whiteboard, and given the vocabulary, they can create their own problems. And then I'll wrap it up with just the idea of review, a big review for a quiz or for midterms or for final exams. So imagine we're in September. A great vertical board starter is the 4-4s challenge. This has gone around Twitter for a while. But basically you have to use 4 4s in any math operation to create answers from 1 to 20. At this one, I do allow them to use 3 markers. Most of the time they can only use 1 marker per group, but we have 3 markers going. And it's so interesting to see the different approaches. Some kids will write all the numbers out. Some kids want to solve them in order from 1 to 20. Some kids just happen upon, one person solves for 8 and the other person solves for 8. You in kind of parallel play here for a little bit. But then eventually they do get to work together, and they usually do get to 20. Sometimes I have to give them a hint and say, what would 4 right next to 4 be? And then they realize they can use 44. Depending on the grade level, I might explain they can use a very excited 4 and put an exclamation point after it if they know what that means, or they can figure out what that means. So again, scaffolding along the way, kind of extending them if they get stuck. Another one to be used in the beginning of the school year, of course, in geometry. As I said, I teach algebra, geometry, and algebra 2. And when I teach geometry, I always tell the kids that it is like learning a new language. We have new notations, drawings, vocabulary words, and just the details on whether it's a segment or a line, whether it gets a capital letter or a lowercase letter or a cursive letter. And I tell them that I'm going to be picky about that on a quiz or a test because everything has its own meaning. So here you can see I'm giving them vocabulary words. I'm spelling them out for them. I'm asking them to underline, write the definition. We have the differences between segments, lines with their notation. So then after this, I would, depending on time, I would have a graphic organizer that maybe is fill in the blank or a graphic organizer that is all complete. I always encourage the kids that they can take a photo of it and then they can have it that way. Yeah. Another reason you can use vertical whiteboards is to investigate. And visualpatterns.org, if you're not familiar with that website, it is fabulous. Fawn Wynn and others have contributed to it, so there are many patterns to investigate. I'm teaching quadratics in Algebra 1 right now, so we are opening every day with a visual pattern. And so on the website, it always asks the kids how many whatevers are in step 43. So I was using this for a few years and I still continue to use it. And then when I went to Twitter Math Camp in 2017, I heard Peg Hagel speak. And Peg is known for PCMI, which stands for Park City Math Institute, which is a 3-week summer program in the summer. And she's fabulous. So she did one little twist and really teased some more out of it. As the step changes, blank also changes. So as adults, we were in our Twitter Math Camp morning group and we brainstormed. We came up with the squares, the rectangles, the perimeter, the height, all of those normal things. And then we were given a couple hours that we could investigate it. We color coded, we made tables, we shared our findings with our group. And I loved it so much that I brought it back to my classroom. So I did the same problem and I phrased it in the same way. As the step changes, blank also changes. So with my students on the very first day of school, we did this one problem for the entire class. And I first had them individually write down the fill in the blank in their notes. Then I had them turn and share with a partner. Then we shared with the class. You can see this picture is a giant sticky note of the ideas that we came up with. And I was very particular, again, on the vocabulary. If they told me the number of squares, I pointed to some squares, some 2x2 squares, and I asked them if that's what they meant. And then we learned that we really should call them blocks instead. So pointing out the differences in vocabulary on the first day was important. Then if I had 6 groups, then we picked 6 of the ideas that we wanted to investigate, and I had them up at the board. So on the first day of school, now they're staring at this blank whiteboard, and they're a little unsure of how to get started. Maybe I suggest a table, a drawing, maybe draw step 4, but really just getting them to be a mathematician on the very first day of school. So here were some of my results. This group investigated the number of steps and the levels. They saw that the columns increased by 2 every step. And you can see that they did draw step 4 so that they could see that. This group investigated the number of blocks, not the number of squares, but the number of blocks. You can see that they wrote down the numbers in each step. Then they saw the differences between the steps. They even concluded that they increased by consecutive odd numbers, and they recognized that the block was the square of the step. This group investigated perimeter. They found the perimeter, and then they even wrote a linear equation for it. I didn't tell them that they had to write an equation. It's only the first day of school, but they were able to put that together. And then I wanted to share all this goodness. So I did do a gallery walk. I gave each group sticky notes, and I asked them to go around and either put a sticky note if they had a question on that group's work, or if they had something that they wanted to state as a notice. What did they notice? So we don't get time to go around to everybody's, but I just watched to make sure at least the board has at least 3 stickies on it. So then I invited the kids back to their original board, and then each of the 3 kids from their group took a sticky note, and they either got to read the sentence that was noticing or read the question and answer it. So on the first day of school, I had every student have a voice, and we had so much work on the board that it was really excited. So I've been using that each year since. I really like that. I mentioned PCMI, Park City Math Institute. I had the chance to attend a weekend a few years ago in December. And so we did 3 days of math, not 3 weeks, but 3 days. And one of the things that we got to do was investigate these numbers. You perhaps recognize them as Pythagorean triples. I gave this to my geometry class. I didn't say that it was Pythagorean triples. I just said investigate, write down everything that you notice. They had their calculators. They were running numbers. They were really seeing a lot of great things. So not always just jumping into a math problem to solve it. I'm really trying to get them to slow down and appreciate and notice things before they jump into the work. Another thing that vertical whiteboards is good for is just looking for patterns, and introducing special right triangle ratios can be challenging. And this is a progression of my oral script that I would have given them. So first I say, go ahead and draw 4 equilateral triangles. So they draw them all that look like that. And they usually don't put any congruent marks on them. And I then suggest, well, if somebody were to walk in the room, would they know that those were actually equilateral triangles? What do you need to show that they are? So they usually go ahead and they put 1 tick mark all the way around. And then I said, but they're not supposed to be all congruent to each other. So it's noticing what the students are doing, and maybe it's not written in my script, but then I need to ad lib a little bit, and that's where it can get a little exhausting trying to make all of these corrections along the way. But again, I can catch it happening in action, so we can make it correct right away. So they add the correct tick marks. I tell them that their side measures are 8, 10, 12, and 15. I then direct them to draw the altitude. They usually don't put the right angle box in there, so I say, how do I know that it's an altitude? So just to keep stressing this, and hopefully that they internalize, and then that becomes their own voice as well. And I didn't take a picture of the final thing, but they did go ahead and they did the Pythagorean theorem so that they found it. They recognized the pattern that the height will have the square root of 3. And then I just throw in there and I ask them, why do you think I gave you a side of 15? And they're like, because it's not an even number and we either have to have a decimal or a fraction. So trying to get them to see the patterns, but then maybe throw something that's a little bit different so that they can recognize that one as well. Deriving things. So going from the Pythagorean theorem to get to the distance formula. When my students come into geometry, they already know both of those, but they may not necessarily know the connection. So here in this script, in this next one, before I clip to the next one with the script, it's interesting because I ask them to write down Pythagorean theorem, and they really struggle with how to spell it, but they get pretty close. But a lot of kids think that Pythagorean ends in an M. So we go over that, we write that down, and hopefully we are now pronouncing Pythagorean correctly. So the script would look something like this, and I always start with my script on paper first. I'm drawing it out with pencil, and then I go to the typed version just so that I can have it. And so it starts with draw a coordinate plane, draw the line segment that is not horizontal nor vertical. So with doing so many of these vertical whiteboards, I have to talk a lot about horizontal and vertical, so the kids have gotten really good with which direction is which. And then I asked them to label it X1, Y1, and X2, Y2. And, they know that from slope formula, but they really haven't had to use it. I asked them then to go ahead and draw the horizontal and vertical segments to create the right triangle. Now add the letters, the lowercase letters versus the uppercase letters, and then give me what A would equal in terms of X's and Y's. Then I asked them to write the Pythagorean theorem, spell it, solve it for C, so you can see they've gotten to the square root. And then I asked them to now substitute in A and B, and they can see the distance formula. So it's kind of an aha moment that the kids would not necessarily make on their own. Geometric mean can always be challenging to teach. And here's an example when I do this, that I give them this triangle. So I would have this printed out and I would give it to each of the groups. But from then on, the directions would be oral. So I gave them the right triangle with the altitude drawn. And I then asked them to draw the triangles so that they are pulled apart into large, medium, and small, so that the short leg is standing up. I will tell you that with this lesson, I started in class and we were doing arithmetic mean first. So they know how to find the mean. They don't necessarily know it's called the arithmetic mean. So we talk about what that means, adding and dividing. And then I introduce them to the geometric mean, which means multiplying and taking the square root. So we look at the formula that x squared equals the square root of AB. Then I show them how it would come out of a proportion. So this is all before we get up to the boards. I show them that if x is a geometric mean in the proportion, it's diagonally across from each other, and then the two other letters, a and b, are called the extremes. Then we get to the board, they get this triangle picture. So after they've pulled apart their triangles, then I would ask them to write the ratio of the hypotenuse to the small leg. And you can see the student said C to B equals A to H equals B to X. And then I would ask them to find the geometric mean. So now they can see it, that it is the B. So I ask them to circle it. I ask them what the two extremes are, C and X. And so we go through all of those different, the three different ratios. And then so exciting, the first time that I did it, one of the students made the connection and noticed that all of the heights were the geometric means. Sometimes I will have the kids notice that it's the parts of the hypotenuse that are the extremes, but this student noticed that the heights were the geometric mean. So I was thrilled with that, and that might not have come out if they were just working on paper. Law of signs is another thing that we can discover. And here this would be another one where I give them the picture, and I would ask them to do the left triangle, call that triangle 1, and on the right-hand triangle, that would be triangle 2. Find the height using sine for both, then solve for h and set them equal. And then we have law of signs, and then we can use it. I remember in geometry, I was crunched for time, so I didn't really have time to then develop the law of cosines. So I thought, well, let's just look at it. So orally, I presented, I said, this is the law of cosines. I spoke it for them, c squared equals, and then I wanted them just to notice. So you can see this student says, looks like the Pythagorean theorem. Little similar to the quadratic formula, very different than the law of signs. There was no division, there was only one angle, and it is solved for c squared. So I think by slowing them down and having them notice the formula, it doesn't just look like a bunch of letters that they have to memorize. I want them really to get to understand it so that they can then use it. Activating prior knowledge is great. Just ask the kids what you're going into, what they already know. So here we were starting polygons in geometry, and I said, draw all the polygons that you know. So they were only supposed to have one marker. The blue ones were the one they were starting with. So it was interesting. Most groups were just drawing the four-sided figures. And so then I kind of had to direct them. And so I might say, why don't you look around the room, see if other students have some more ideas. And then I could say, well, could the polynomial have more than four sides? And then what is it called? So then they picked up the green marker and they started going, and I remembered. And in my class notes, that's where I'm usually making notes of the funny things that kids do or say or mistakes that they made so that I can have them for the future. But one student asked if a rhododendron was a type of polygon. So I thought that was cute. Making connections. This is important. Open Middle is another fabulous website. And the way that Open Middle problems are designed is you can try to use numbers 0 through 9 without repeating them to fill in the blanks. And they have a whole bunch of Open Middle problems that you can check out on the website. But this was an Algebra 1. We had already done slope-intercept form, standard form, and perpendicular lines. And then this was tying it all together because, again, they understand the idea that perpendicular has opposite reciprocal slopes. But what does that mean? Where do the numbers have to go when you're trying to switch from slope-intercept form to standard form? And where the heck is that number going to come in? So they're drawing sketches and they're trying not to repeat any numbers. And this is a really good culminating problem for perpendicular lines. Open middle in Algebra 2. Here again, we're making connections. So I would use this after I've taught all the different forms of the quadratic, vertex form, factored form, standard form, and I let them have at it. They can't repeat the numbers. And I remember in this one, I asked them to share their strategies. Which one did they start with first? Which one did they go to second? And that's always interesting. Some kids go straight down. Some kids will jump to factored form and then multiply that out. So sharing the strategies and seeing that there's not just one way to get an answer is really important. And I think that they're seeing that. Here's another example where I direct taught first and then have the students up to the board to apply their work. When they are learning vectors in geometry, it's really the first time that they are seeing them, seeing their notation. So we go through that, we draw a few in our notes, and then we get up to the board. Here they also have some new vocabulary with magnitude and the direction. So the first and second picture, I had just given them the vector, so they had to practice writing the notation, drawing the vector. In this picture, you can see those are my magnetic graphs that I got as part of my grant. So I like to use those a lot. And I didn't take a picture of them finding the direction, but they did have to find the magnitude. They did have to find the direction. So applying it right after learning it through the direct teaching is really important there. Any time you have to have them draw pictures, word problems, trig problems is a great time because they can be creative. Again, they love to be drawing up at the board. Here we have our typical shadow question. And once they draw their first picture, really pay attention because for whatever reason, kids like to put the shadows on the hypotenuse. So somebody will do that. I will carefully, politely point it out. Where is the shadow? That should be along the ground. So that we can fix that mistake before it takes on. Here's another picture. I just put this one in just because I liked the part about the stop sign. And I think I made a note of this. That's why it's typed up to ask if a stop sign is a hexagon or an octagon. And that always makes for an interesting debate there. Dilations, that can be a little bit dry, but with the magnetic whiteboard, graphs, and we can get up to the board so they are going ahead and connecting their triangles. I had them find the dilation. Is it an enlargement or a reduction? And then I gave them a yardstick and I asked them to find the point of dilation. So I hadn't really talked about it or how to find it, but this group was pretty proud. This was them when they're sophomores and now they're seniors this year. So they had that beautiful graph that was done on the whiteboard with the yardstick, and they were able to find that point of dilation. This problem, I teach linear programming in Algebra 2, and we have touched upon it in Algebra 1. They usually don't totally grasp it in Algebra 1 because it is such a multi-step problem. But then I didn't want to reteach the whole thing in Algebra 2. So here's an example with spiral review. You can see that I have a piece of paper tacked up there on the board, and that walks them through all of the things. So it's not me at the board directing them or doing it orally. So here they can go at their own pace. You can see I took a picture of this group because it was so nice and neat, but they identified the variables, they wrote their constraints, they graphed their feasible region, and all of these vocabulary words are important. So on my paper for them, I have them bolded and underlined so that they can remember those words. When we come back to recap after the board work, then I can just go through the vocabulary and we can put that into our notes because now they've actually already used it and then they know that that is the feasible region. Surprise mistakes. So I already pointed out that one of the reasons I love to do vertical groups, vertical whiteboards, is to find the mistakes. So I just made this one up this year for Algebra 2. And this was the 4th problem out of 4 in the class. And we had done some harder trig problems. And I threw this one in there. That's supposed to be a theta at angle B. And so the sides were 3 and 6. And I almost didn't do it. We were kind of running out of time. I'm like, oh, well, this one's too easy. And I'm wondering if you know what the mistake might be here. I will let you know. So we have 3 on the leg and 6 on the hypotenuse. So they go ahead and they do the Pythagorean theorem. and they come out with 5. And I say to them, oh, it's the famous 3-5-6 triangle. I haven't heard of that. And we've already been doing a little bit trig at this point and having to rely on the Pythagorean theorem. And I do stress, I say, do the Pythagorean theorem slowly. Don't make it turn into numbers that you want it to turn into, because as a teacher, I will do that as well. So it was interesting because one group made this mistake, and then in the next class, 3 other groups made the same mistake. So trying to point that out, to be really careful with the Pythagorean theorem before you move on to use it for trig. Anticipating mistakes. So the more you get to do this, you'll know where the kids might trip up, especially with trig, drawing angles of elevation and depression. As you can imagine, they might make mistakes. So this was an oral problem. It actually was a textbook problem. And in the textbook, it had the tree, the falcon, the mice, all of the lines drawn in, everything was labeled. And it practically handed the problem to them. But then I took all of the words away and I described it to them. They get great with their drawings and their falcons and their mice. But then they made some mistakes in their drawing, and some where I thought that they would be. So this person is correct. It was interesting because they didn't show the angle of depression up top, as I said that it would have. The falcon is having the angle of depression looking at the mice down on the ground. But this person did it correct. And I'm kicking myself because I didn't take a picture of the other mistake that some group made. So they put the 62 in the outside angle there, and then they put 10 where the 72 would be, because I said it was 62 and 72. So they said the difference was 10. And I'm like, how can that be a 10-degree angle? And again, more than one group did it. So I'm always fascinated by when I find these mistakes. I will write them on my notes, save them for next year, and try to catch them next year as well. When you have the kids working in groups, you can give them a challenge problem, kick it up a notch. So this is in Algebra 2, and we'd already gone through all of the properties of logs. They have been converting between log and exponent form, but they hadn't seen something like this with 2 different bases. So I orally gave them the problem, and I let them spend some time with it and try to figure it out. And they kind of pull it apart and go to log form and eventually get there. But you can give something more challenging because you have those 3 students working together, and just listen to the conversation and watch their strategies. It's so interesting. Giving different problems and open-ended problems are fabulous for vertical whiteboards. Here's another beginning of the year. I did this in a geometry class. I said, go ahead and draw the circle, because of course they love to draw circles. And it's going to be a clock, and I want you to use order of operations to get the different times. And then we did a gallery walk and we looked around. We were looking for creativity and the different types of problems, and also trying to find any of the mistakes. Another example of giving different problems, and this was Algebra 1, and we were looking at the tables, the graphs, and the data, and then I asked them if they were linear or not. So I gave each group a different type of problem. They had to do a table, a graph, an equation, and then decide if it was linear or not. And then we did a gallery walk to share. By the end of Algebra 1, where we've done linear, exponential, and quadratic, I can see doing this one again and mixing them up and giving somebody linear, somebody quadratic, and then they have to determine which model represents it best and then write the model. So that's where I'm going to go towards the end of this year, hopefully. Algebra 2 and the unit circle. This is a fabulous one to put up on the board. Again, kids love drawing on the board. They aren't so kind or fond of the unit circle, but putting it on the board is fun. So again, they get to draw a nice big circle. And it's so interesting to watch their process. When I create the unit circle, I usually put all the degrees, all the radians, and then the points. Sometimes the groups will work in the first quadrant and then just translate along. Sometimes they'll draw the triangles right within it. But just seeing for me, just to watch them and see them work and see their strategies, see how their brain's working, but then also for them to look around and see how other kids are doing it, I think it's so powerful. So then in this one, after they all have their unit circles drawn, I let them know that we're going to just switch one group and we're going to see if we can find any mistakes in their work before I ask any questions on it. But the groups don't want to leave their group. They want to make sure that they have all their work correct, because they don't want anybody to find their mistakes. So then we switch. We maybe don't find any mistakes. We come back, and then I just ask some sample questions like, what is the sine of 2/3 pi? What is the tangent of 3 pi? And it's based off of the work that they were doing. Somebody's asking if I let them draw freehand. No, yeah, these are all freehand. We do a lot of circle practice. One other thing that Alex Overwick is known for is he is the world champion circle drawer, and he shared that with me at NCTM. And I actually had one of my classes that was obsessed with drawing circles, so we Skyped with him and he showed us how to draw perfect circles. So we're pretty good circle drawers. Checking for understanding. In Algebra 1, we've gone through polynomials. We've done all of the words of classifying them by degrees and by number of terms. So, with the operations, it can be a little dry, add, subtract, multiply. So here was what my board script would look like. Go ahead and write quadratic trinomial A, write quadratic trinomial B. Now add them together. In my script here, you can notice I asked the group to check their work. I'm checking their work, of course, but I asked the group to check. And then I even make notes of, should they erase it all before they pass the marker, or do they keep some of it, or do they keep all of it and pass the marker? So I make all of that just so that it can make the transition between problems a little clearer, because I might not remember that I wanted them. Then they may erase and they weren't supposed to erase. So we go through those 3 problems. And then problem 4, and this actually came from my colleague, Kathy, so I'll give her credit for it, was to have the team create an original problem, whether it's add, subtracting, or multiplying, and then they were going to move over one station and do that group's problem. Well, they wanted to create very difficult problems, so they made them super hard with negative exponents and really big numbers and multi-step, that by the time they moved to the board, they really couldn't do the problem, but they were trying to get creative there. And this was still with the same day, some more open middle problems. So problem 5 and 6, again, this was just, this one I verbally said to them, so I would read it as blank x squared, and then they had to fill in the blanks with 0 through, I think, 1 through 9 without repeating on these problems. Final exam review. So in my geometry class, I do allow the students to make a reference sheet. So for the final exam, I broke the semester up into chunks. I allowed them to work in groups. They could have more than one marker. They could go back to their notes. They could use Google, but they'd have to come up, say, with everything that has to do with right triangle trig or similarity and geometric mean, and they could write everything on the board. And then they would go around to all the different groups and they would copy those down onto their reference sheets. I knew that we would run out of time in class, so the kids could take pictures and then copy them off the pictures, but I also took pictures of their work and then put it into a Google Doc for the class so that they can then use that to make their own reference sheet. So just some things to keep in mind when you are creating your own type of vertical whiteboard problems is, of course, with any math problem, you want to try to connect it to something they already know. I can't stress enough, you have to give attention to each word in each question, whether it's a direction, a unit, a measurement. Have a piece of paper, try to write it out so that you can make sure you're giving enough information, like overdo it. You can always leave some words out if you need to, but you want to have more than you need to on your script. Anticipate those common mistakes and build in problems that might lead to those common mistakes so that you can have a discussion about it. Scaffold, 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 lots of questions, notes to yourself, again, when to pass the marker, when to erase, all of those things are going to be important. And if you want to ask questions, so maybe they finished the problem and now you want to ask questions to allow students to find their mistakes on that. What would that look like? And on your script, make sure you include all of the calculations on all of your answers so you don't have to stand there calculating it, but so that you can see their mistake easier. The last 2 bullets, when will the new person get the marker and when will you erase all or some? So Peter does suggest 1 person with the marker. I have pointed out a few when I let the kids have all the markers going, but 1 marker is what usually works best. Then the other 2 students are kind of looking over their shoulder, telling that person what to write, doing the calculation on the calculators. So 1 marker is an important part of this. The students are catching on to me. I try to make the problems progressively harder, but I would suggest mixing it up because now they realize they just want to do problem one because that's usually the easiest one. So go ahead and make the first one most challenging, and then it will be easier after that. So they've been up to the whiteboards, and I didn't really touch on it, but I don't use whiteboards every day. I don't use whiteboards for every single period, like the entire period. It might come as an opener. It might come at the end as a practice, as an exit ticket. It might come in the middle, and then we come back and recap. So whatever you need it to be in your classroom is what it can be. And so after the boards, even if it takes up to the bell, I try to cut them off so that we can at least come back and recap if it's just me doing it orally, or recap with blank notes, fill in the blank notes, or already finished notes. Because it's not really about the notes, it's more about the practice. I want them to have the notes so they can refer back to it, but it's about putting it together in groups through discussion at the whiteboards that's important. And if you have time, asking the students to share their process. The kids love to speak. They're so proud of the work that they have up there. Rather than just erasing it, have them share that. Gallery walks are awesome. And then looking at other students' works. I wanted to put this in here because when I started it, it is oh so tiring. You are managing a truly collaborative classroom, and that's tiring. So you have to be ready for the chaos. You have to get comfortable with it. There is a lot of conversation. It's loud. There's movement. They're poking each other. They're sitting down. They're standing up. They're going to different groups. It's like herding cats. There's a lot of anticipating as the teacher what might come next, what direction that they might go in, a lot of redirecting. But learning is messy and learning is happening. So that's why it's tiring. But the good side effects, vertical, everyone can see everything. It leads to great conversations, discussions, debates. You share strategies, make common mistakes. The non-permanent allows the kids to get started right away. They have less fear of making a mistake. The oral invites all of the students into the math problems because they don't get stuck on the words. And then the visual random groups, the students learn to work with everyone. So my call to action and what you could do next is take a risk. If you haven't tried it before, invite the students up to the board, make some groups, ask them to come up. And I would suggest starting with an open middle or a visual pattern. So here's a link to my presentation. And then I also included a link to my lessons. And if the links aren't working, please let me know. But I've grouped them into Geometry Algebra 1 and Algebra 2 lessons. And then just one final piece, Peter actually reached out to me on Twitter and told me that he's writing and publishing Corwin's publishing a new book this fall. It's called Building Thinking Classrooms in Mathematics, 14 Practices for Enhancing Math Learning. So that's what I have for you tonight. So now how does this question and answering part go?
Thank you. I think there's a little bit of feedback right there. Sorry about that. There's just a few questions people had. I mean, you might have answered some of them. I know somebody talked about, explain more about passing the marker, but then you did talk about that. So I think Diane's question might have been answered. And then Jara Wood asked, what are the next steps towards a thinking classroom after doing VNPS and VRG? Like, how do you get them to continue to think? Or I'm not quite sure what else Jara was interested in possibly.
Right, yeah. So as I mentioned, we're doing the quadratics in Algebra 1 right now. So every day we're in the routine of being up to the board for a visual pattern. And then I'm putting the visual pattern on the quiz. So I give them the website. Here's the website. They can practice them. So just seeing other people's strategies so that they can then take their own strategy as they work on the problems.
Okay. I think we got Bitly's on the slide right now. There wasn't any other Bitly's that you were sharing.
No, there wasn't.
Okay. So Anne, the Bitly's are right there on that slide for you. And I'm sure that if you reach out to Jennifer, if you ever have any questions, she would be more than happy to answer them. And I would encourage you to read her blog if you have not done that at any point. Can you remind us of your blog address again?
Yeah, 8 is my lucky number.blogspot.com. I do see one question about successful for a class of 30. First off, I'm so sorry you have 30 kids. That is a large number. If you have space for 10, then you could maybe make it work. You might be at the windows. You could get the big sticky notes and you could do that. It would be loud. It would be a lot of movement. It would have to be something you are comfortable with. Tips for getting the school administration to let you do it. I love to invite my administration to come in and see it, and they're very impressed. So I would just say, go ahead and try it and invite them in to see. You can't go wrong with it.
Okay, are there any other questions for Jennifer? I like Amy's suggestion to do it and ask for forgiveness later.
Yeah, I saw that.
Yeah, I mean, depending on the culture of the school, the students might not even really want to talk to each other. It's like, wait, we're allowed to do this? We're supposed to be talking to each other? To a certain extent, I've been in situations like that. If the culture of the school is more like you just are supposed to be sitting and listening and not talking or saying anything, it's definitely a culture shift for some students.
Yes, it does. It takes them a little getting used to it, but my kids love it when they come in, they see board problems. They're like, yes, we get to do board problems. They're excited to see who's going to be in their group, and they're excited to see what kind of work they're going to be doing.
All right.
Well, thank you so much for everybody coming. And I wish you luck with all trying to go to remote here in Massachusetts. We are all shut down for at least 3 weeks. My son was supposed to get married on April 17th, so we've had to move the wedding to May 17th, and we're hoping that gets us out of the danger zone. But lots of things are changing so quickly, and I wish you all good luck.
Thank you very much for presenting tonight, Jennifer. And I hope people can make it next week as well. Our session next week is Girls with STEAM, Finding Opportunities to Enrich and Empower Girls in Education. The recommended grade level is K through 12. And that's going to be presented by Natalie Latrice Hulleman and Girls with STEAM. So I hope to see several of you next week. Have a good evening, everyone.
Thank you. Good night.